This video, we're going to graph some sine and cosine graphs. Suppose you were asked to graph y is equal to the sine of x minus pi. Well, this is a positive sine graph. So I draw one period of the sine graph. And I like to know where it starts and where it finishes. Well, sine and cosine graphs always start when the angle is equal to 0. And like always, if you subtract two things and you get 0, that is, they have no difference, that's because the two quantities are equal. Okay, it starts at pi. Where does it finish? Sine and cosine graphs finish where the angle is 2 pi. Well, how many pi's should you have? So if you take away a pi, you have 2 pi's. The answer, in my opinion, is pretty clear. It's when you start off with 3 pi. So this is 3 pi. So in between 1 and 3 is 2. 2 pi. In between 1 and 2 is 1.5 pi. Between 2 and 3, you can add them up. Take the average. Get 5/2 pi. Now, this distance is 1 pi. So, I need to go 1 pi to the left of 1 pi to find the origin. So I go maybe that amount, and here's my y-axis. And this number in front, or at least understood to be in front, the absolute value of that number is the high, and the absolute value and the negative absolute value of that number is the low. And there is one period of this graph. Please understand that the graph goes on in both directions forever and ever and ever. But there's one period of it in the yellow, and I drew it before I did anything. The first step was really drawing it. Suppose you want to graph y is equal to 4 times the cosine of x plus pi/2. This is a positive, because 4 is positive. This is a positive cosine graph. So, the first thing I'm going to do is draw a positive cosine graph. Here it is. I even know that's the x-axis. Just don't know where it starts and finishes, or where the y-axis is. But now we're going to find that. It starts when the angle is 0. If you add two things and you get 0, then the two things were just opposite in signs. Pi/2 is positive pi/2. So x must be negative pi/2. So that's where we start. Negative pi/2. Where we finish is where the angle is equal to 2 pi. Now, don't get caught up on the pi's. I mean, what plus a half equals 2? The answer is 1.5. The answer is 1.5. 3 halves. So x should be 3 halves pi. I mean, what you can do is think of this as 4 pi over 2. That way when you take away pi over 2, you have a common denominator. On the left side, you just have x. And on the right side, 4 pi minus pi is 3 pi over 2. So, we now know where it finishes. Finishes at 3 pi over 2. Now, everything is pi over 2. This is negative 1 pi over 2. So, what's in the middle? Well, add them up and divide by 2. You get 2 over 2, which is 1. 1 what? 1 pi over 2. What's in between 1 and 3? 2. So you get 2 pi over 2's, which is just pi. This is a good one. What's in between this number and this number? 0. I like that because now I know where my y-axis is. And the highest number is the absolute value of 4. That's called the amplitude. And the lowest number is negative the absolute value of 4. And once again, not only am I done, but I graphed it before I did anything. And one last thing, please remember this is just one period. It goes on and on and on. Now just for the record, a classmate of yours may have drawn this one. Okay? That doesn't mean he or she is wrong. Doesn't mean you're wrong. There's infinite number of periods. A period is a full cycle from here to here. It's a full cycle. Another classmate could have said, there's my period. Of course, they're going to have to label the important values. There's 5 of them. 1, 2, 3, 4, and 5. And there is that graph. Suppose you were asked to graph y is equal to negative 2 the sine of 3x minus pi. Well, this is a negative sine graph. That just means that instead of going like this, I go like that. I draw it upside down. So there's my graph. Let's find out where it starts and finishes and where 1, 2, 3, 4, and those 5 values are. Well, it starts when the angle is 0. Again, if you subtract 2 things and you get 0, just write down the 2 things are equal. Divide by 3, x is pi over 3. Okay, pi over 3. The finish is when the angle is equal to 2 pi. Well, I think it should be clear. If you have 3 pi's and you take away a pi, you'll have 2 pi's. But if you insist, you can add pi to both sides, and you get 3x is 3 pi. So x must be pi. Okay, so x is pi. So now, what's the middle? What's 1/3 plus 1 over 2. That is, what is, remember this is 3/3. What is 4/3 divided by 2? It is 2/3. 2/3 pi. 1/3 pi, 2/3 pi here, and then 3/3 pi. Okay, wonderful. Now, this here, see, there's no space between 1 and 2. I mean, it's 1.5. So, you have 1.5 over 3 pi, which is 3/2 over 3, which is a half. Or you can think of this as 2/6 pi, and think of this as 4/6 pi. And I know what's in between 2/6 and 4/6. It's 3/6, which is a half. Or, now these steps have nothing to do with trigonometry. It's just taking the average of two numbers. What's in between 1/3 and 2/3? You add them up, you divide by 2. You get 3/3 over 2, which is a half. Half what? Half pi. What's in between 2/3 pi and 1 pi? That is, what's in between 2/3 and 1? One way of doing it is to add them up and divide by 2. 1 is 3/3. So you get 5/3 over 2, which is 5 over 6. Or we can think of 2/3 as 4 over 6, and 1 pi, that's 6 over 6 pi. And what's in between 4 and 6? 5. 5 what? Pi over 6's. Okay. Just add, find the middle however you like. But it's not trigonometry. It's literally arithmetic. Now, this distance here from pi over 3 to 2 pi over 3, that's pi over 3. Oh, and since this is pi over 3, I want to go to the left exactly pi over 3 to get to 0. Now, nobody's going to take a ruler out on you and make sure that these two distances are the same. But it has to be reasonable. You can't put the y-axis right here. This distance and this distance are nowhere similar. Likewise, you can't put the y-axis over here, or even further to the left. Even further to the left. It's not reasonable for you to think that this distance and that distance are the same. Again, your teacher shouldn't take a ruler out on you, but it should be reasonable. Now, what's the highest value? It's the absolute value of that number. So, the highest value should be 2. The lowest value is the negative of the absolute value of this number. The absolute value of that number is 2. So -2. And there's your graph. And I drew it first. At least you get credit for drawing a negative sine graph. Suppose you were asked to graph y is equal to negative a half cosine of 3x plus pi. Since it is a negative cosine graph, I draw my cosine graph upside down. There it is. And then for the start, I let the angle equal 0. Bring that over. You get 3x is negative pi. Divide by 3. And now you know what the start is. Starts at pi over 3. Where does it finish? Well, how many pi's should you have? So when you add pi, you have 2 pi's. Another pi. 3x should equal pi. So x is pi over 3. And that I like because I know what's in the middle of negative pi over 3 and pi over 3. It's called 0. Okay. So I have this point. I have this x value. I have that x value. This x value is 0. I just need to find this one. Well, what's in between 0 and a third? I'll put the pi's in after. Well, this is 1/3 divided by 2, which is 6. So here you have 1 pi over 6. And here it's going to be the same. It's going to add up to negative a third. Divided by 2, you get negative 1 pi over 6. And the highest value is the absolute value of that number, which is a half. And the lowest is negative a half. And there is your graph. Just label the y-axis and you're done. Start and finish. If you want to know the amplitude, it's just the absolute value of that number. The phase shift is where you start. X equals pi over 3. Negative pi over 3. It's where you start. And the period, now sometimes it'll be negative, but generally the period is the finish minus the start. Just in case it's going to be negative, we take the absolute value. It finishes at pi over 3 minus, it starts at negative pi over 3, and in case it's negative, absolute value. Well, there's a rule that says you can change addition to subtraction anytime you want, as long as you change the sign of the second number. And there's an equivalent rule that says you can change subtraction to addition like I just did, as long as you change the sign of the second number. And that's going to be 2 pi over 3. And since it's positive, there it is. That is the phase shift. Sorry, the period. The period is 2 pi over 3. We can go back to the earlier graphs and do this as well. The amplitude is the absolute value of that number, which is 1. The phase shift is where it starts, x equals pi, and the period is the finish minus the start. Well, if you go from 1 pi to 3 pi, it's 2 pi. Or if you want to do the finish minus the start, you still get 2 pi. The period is 2 pi. This graph here, the amplitude is the absolute value of that number. the phase shift is where it starts. X equals negative pi over 2. And the period is the start to the finish. Well, the units are pi over 2. How far is it from negative 1 to 4? Sorry, from negative 1 to 3? It's 4. 4 what? Pi over 2's. It's 2 pi. You want to go the finish minus the start. That's okay. The denominators are the same. 3 pi plus pi is 4 pi. Divided by 2 is 2 pi. In this one, the amplitude is the absolute value of that number. The phase shift is easy. It's where you start. And the period, that one, you have to do a subtraction. If you go from pi over 3, so pi minus pi over 3. Pi minus pi over 3. You know, you could ignore the pi. You really need to do 1 minus a third, which is 2/3 pi. And just in case it's negative, take the absolute value. So the period is 2/3 pi for that graph. So now let's up the level of difficulty. Suppose you want to graph y is equal to 2 times the sine of x minus pi, but now we're going to add 4. Well, let's find, so in our sine graph, you have the high, you have the low, and you have the middle. The high, the middle, and the low. Now, ignoring the plus 4 for a moment, the high is 2, the low is negative 2, the middle is always 0. That's just for this graph, but every y value is being increased by 4. So the high is going to be at 6, the middle is going to be 4, and the low is going to be at negative 2. Okay. So what I'm going to do right now is I'm going to draw the y-axis, but it's probably in the wrong place. The high, so I'm going to erase it, I bet. 6, 4, and 2. So it's like that's the regular origin. And I draw a positive, because 2 is positive. I draw a positive sine graph, where the highest went to 6 and the lowest went to 2. So I guess that means that for sure the x-axis is there. Again, I don't promise that that's the y-axis. It'll be a coincidence if it is. Okay, so what is the start? Well, the start is when the angle is 0. Again, if you subtract two things and you get 0, those two things are equal. So it starts at pi. And it finishes when the angle is 2 pi. Well, you need 3 pi's, so when you take away pi, you'll have 2 pi's left. So x is 3 pi. 3 pi. And of course, this is 2 pi. So it turns out that this distance here is 1 pi. Okay, let us get rid of the y-axis. And let us move from pi. I have to move pi units to the left. I go pi units to the left, and there's my y-axis, and I didn't even have to erase those numbers. I lucked out. Okay. So what's in between 1 and 2? 3/2 pi. Again, you can add the 1 and 2 and divide by 2. What's in the middle of 2 and 3? You can add them up and divide by 2. It's 5/2 pi. So I labeled the 5 important points: the start, the finish, the middle, and the quarter points. 1 pi, 1.5 pi, 2 pies, 2.5 pies, 3 pies. And there's your graph. In my opinion, this helped. It didn't make adding that 4 off the wall hard. Let us try another one like that. Suppose you wanted to graph y equals -3 cosine of x plus 2 pi minus 1. High, middle, low. Normally the high is just that absolute value of that number, the middle is 0, and the bottom is negative the absolute value of the amplitude. So now we have to take away 1. So this is 2, -1, and -4. So if I draw a y-axis, it's most probably in the wrong place. So looks to me like the x-axis is right there. And I draw a negative cosine graph. Again, where that's the low and that's the high and that's the middle. So we make believe that's the middle. Negative cosine graph goes like that. So we're going to want to know this value, this value, this value, and this value, the x values. We know the y values. They're already listed. Okay. So where does this graph start? X plus 2 pi is 0. Bring that over. So it starts at -2 pi. -2 pi. Okay? And where does it finish? What plus 2 pi gives you 2 pi? Well, that's pretty nice. That's 0. So it finishes at 0. So it turns out that the y-axis should be right here. And this should be -4. This should be -1. This should be 2. And I erased this. It was very helpful. We say thank you for assisting us. And that's that. Okay. Now I need to find, well, I found this x value. I need to find this x value, and this x value, and this x value. I already know it's 0. Oh, and I need to find that x value. Well, what's in between 0 pi and -2 pi? Answer, -pi. Now, you have to start catching on. This is going to be -1/2 pi. -1 pi is right here. -1.5 pi is right here. And right here is -2 pi. Label this the y-axis and be done. That finishes this one. Now, what we haven't been doing in the last couple of problems is finding the amp, the phase shift, and the period. Well, the amp, nothing changes even though we have this -1. The amp is the absolute value of the -3. The phase shift is where it starts. And the period is the start minus the finish. Well, I would hope that you can tell that that distance is 2 pi. But if you need to, it's the start. Sorry, it's the finish minus, that's the finish minus, and that's the start. We can change and change, and we get 2 pi. And again, just in case it's negative, put absolute values. 2 pi. For the last one, what's the amp, the phase shift, and the period? Well, the amp is the absolute value of that number. The phase shift is where the graph starts at, x equals pi. And the period, well, it goes from 1 pi to 3 pi. That's 2 pi. If you need to, you can do 3 pi minus 1 pi and get 2 pi. And that's the period. And just in case it's going to end up negative, make it positive. This completes the section on sine graphs and cosine graphs. First, draw the graph. Now, of course, if you have a plus or a minus here, first do this step, and then draw the graph.